Howdy, looking at section 3.1, and it is October. It is spooky. That's why we're talking about imaginary numbers. And so this is where we have the square root of -1, which is going against the definitions of square roots, because we simply can't have the same number multiply and give us a negative. So that's where we have this an I here. And then this is where we say our real number is A, and plus BI format is how we always write our imaginary numbers. And so our imaginary numbers are always going to come in one of four situations. So we can have I, which is the square root of -1. And then we can have I squared, in which we get rid of that square root and we just get -1. And we have I cubed, which we're just taking -1 times I to get -I. And then we have I to the fourth, which is just taking -1 times -1, giving us 1. Then we continue this process. So I to the 5th power is the same as I to the 6th power is the same as I squared. I to the 7th power is the same as I cubed. And I to the 8th power is the same as I to the 4th. And this pattern continues. And we will see this later on in the lesson. So this first one, we're identifying which part is real. As you can see here, we don't have anything there. So 0 is that. And then when we're identifying what is imaginary, we're going with what is our B stated up here. So the number in front here is -4. Then we have to say, is this a non-real complex? Is this pure imaginary? Or is it a real number? So in this case, it is non-real complex because we have it in this A plus BI format. And it is also pure imaginary because we just have BI. 2 is the same thing. We're identifying the real, which is 1. And the imaginary, which is 3, and this would be an example of non-real complex. Now looking at the rest of these, all of these are pretty much gearing us up for like the last two problems in this lesson. We have to be able to do all of the different operations with imaginary numbers. So first step is just to distribute, and it's the same. So we're making sure we multiply everything by 3i. Here this gives us -12i, so we can't do anything with that. Here we get positive 18i squared. So looking at this little tree, you can either write this tree down, or you can memorize it, or you can simply know that I squared is -1. And then when we multiply it times 18, we get -18. So just always make sure you're writing this in the format of A plus BI, so the -18 comes first, minus the 12i. Here we want to separate, so the square root of -1 times the square root of 64. This square root of -1 becomes I. The square root of 64 becomes 8. And same thing with the 5. We want to make sure we keep this negative on the outside. We can't simply just distribute that and we get rid of the negative. That is a no-no. So we have the square root of -1. That becomes I. The square root of 121 becomes 11. And that negative on the outside remains. Same thing going on here. We separate the square root of -1 and the square root of 14. We can't simplify this, so this is just an example of we don't want to write the square root of the I in the square root because you can't tell if the I is underneath the square root, so we just put the I out front. And then here, more of the same, except now we're given a real number, so we separate the square root of -1 and 49. That reduces the 7i, and we are done. Here, we want to make sure we keep that negative separate here from the square root of -1 and the square root of 63. Here we just separate this, so I have the square root of 9 times the square root of 7. That is also the square root of 63. I can reduce the square root of 9 to 3. And now when I put this back over here, the square root of -1 gives us that I. That minus comes down, the 4 comes down, and then there we have it. Here we have I is given to us. We're multiplying that times the square root of -1, which is I, so that gives us I squared. The square root of 49, that gives us 7. I squared is -1, which gives us -7. Here we're multiplying, so we make sure we take out all of our square root of -1s. That is I, that is I, that gives us I squared, which gives us -1. And then I simply write out a product of primes. And so 8 is square root of 2 times the square root of 2 times the square root of 2, and then times 13. Square root of 2 times the square root of 2 is simply 2. And then these leftover prime numbers, we multiply them, so that becomes the square root of 26. I multiply the 2 and the -1. Voila. Here we are dividing, so make sure we separate. So I have the square root of -1 times the square root of 700, which can become the square root of 7 times square root of 100. And on the bottom, I have the square root of negative 1 times square root of 100, and we can cancel. So those cancel out, boom, 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 leaving me with root 7. Here, once again, we're taking out the square root of negative 1. Writing out a product of prime numbers here. Since it has a square root of 6 on the bottom, I'm just going to keep the square root of 6 on top. Easy to see that we can cancel those. Then this gives us I root 13. Here, more of the same, separating this into a product of primes and separating our square root of negative 1s. That gives us I times I, which is I squared, which ends up negative 1. Root 2's cancel, and I have root 5 times root 5, which just gives us 5. Here we're simply adding these, so 9 plus 9 is 18. 7i minus 6i is minus I. Here, make sure you distribute this negative, so nothing changes in our first parentheses. So we get negative 8 minus 3i, and then plus 1 and plus 3i. Now we collect like terms. Negative 8 plus 1 is negative 7. Negative 3i plus 3i is eliminated. Here, we've got to do more of the same. We need to distribute those negatives and collect our like terms. Here, we don't have to distribute any negatives. We're just collecting like terms. Everything gets eliminated, so it's just 0. So you don't need to put 0i. Here we are foiling first, outer, inner, last. So this needs to happen. So you're going to see a pattern that happens each time that we do something like this. I'm showing each step every time because, well, you're learning it. All right, so we have 8 times 2. That's first. That gives me 16. 8 times negative 6i gives me negative 48i. 7i times 2 gives me 14i. And 7i times negative 6i gives me negative 42i squared. And as we've learned earlier, I squared is negative 1, so that negative 42 becomes positive 42. We collect our like terms in the middle. That gives me negative 34i, and the 16 comes down. Now I have like terms here. That gives me 58. Nothing happens to the negative 34i, and we are done. So this will be the process when foiling. Once again here, so we FOIL out, collect our like terms, and simplify. Same thing here with 20. We are foiling. We're going to be doing lots of this, so just take your time with it. You can either do like I'm doing here, or you can skip some steps, whatever you feel comfortable with. In 21, you could say, hey man, that's a difference of 2 squares. I know that those middle terms are going to cancel out time. Or you can simply just FOIL it out and allow math to happen. So when we do have the same terms, except one is plus and one is negative, this is called the difference of 2 squares. And therefore, these middle terms, as you see, cancel out. Voila. So you can either do it the long scenic route, or you can simply take the short route, realizing, whoa, 22, we also have a difference of 2 squares. So those middle terms will cancel out, as you can see here. And then the last thing we do there is distribute that I on the outside. Here we are squaring this, and so I just wrote it out long ways like this and FOILed it like so, keeping that 3 out there, waiting and lurking in the distance. We take care of that, multiply by the 3i, and then reduce. Now here's 24, 25, and 26, which I am referring back to this initial little chart that's drawn out here. As you can see, everything four, there are 4 quadrants, there are 4 possibilities, which is why in number 24, we are dividing this exponent by 4. There are 4 possibilities, right? Or there are so many rotations that we go through. So in 21, I either go around that quadrant 4 times, or I simply go, well, I can just take out each of those rotations. So I divide, and my remainder is 1. So instead of looking at I to the 21st power, I can look at it as I to the first power, which is simply I. Going to follow that same thing, dividing by 4. 31 divided by 4 goes into it 28 times with 3 left over. 3 is our new exponent, so I to the 31st power is the same thing as I to the 3rd power, which if we look back at that little quadrant, that means we get negative I. And then I to the 16, we divide it by 4. We get I with a remainder of 0, and that gives us 1. Looking at these next ones, we have negative exponents, so we need to write that so that it has a positive exponent, so that is 1 over I to the 18. I do the same process of dividing that exponent by 4. My remainder is 2. I to the second power is negative 1. Now I can replace 1 over I to the 18 as 1 over negative 1, which is negative 1. Here we have 1 over I to the negative 25th, which means we can write it as I to the 25th, which means I just divide that by 4. My remainder is 1, leaving it I to the first power, which is just I. Next up, we're looking at the conjugate, and this is when we're going to start to simplify any type of complex number when we're dividing by a complex number. And so here, I just simply change whatever my imaginary sign is. So since it's plus 5i, my conjugate is minus 5i. So 9 minus 5i. Here it is 0 minus 22i, so my conjugate would be 0 plus 22i, or just 22i. And here we're going to actually use multiplying by the conjugate. My denominator has negative I, so my conjugate is positive I. So our conjugate is I. We multiply that, we get 2i on top, and then on the bottom we get negative I squared. I squared is negative 1. The opposite of negative 1 is positive 1, and that reduces to 2i. Looking at the conjugate again, so everything in this whole section is building up to these last two problems. So my conjugate here is 1 minus I, as you can see. We do have to FOIL on the numerator and denominator. We handle that out, just like we've done earlier. And then at the end of this, if you have anything that can reduce, you simply reduce it. So one easy way of doing this is just separating it and dividing both of the terms in the numerator by the denominator, and that gives me 8i. Follow these same steps here. So my conjugate is 7 plus I. I follow through and FOIL both the numerator and the denominator. And then I come out here, and this is reduced to 6 over 5 minus 2 over 5i. I believe it wants you to write it in this format instead of writing it as 6 minus 2i over 5. So make sure you separate that.